all-purpose computer systems for business, large systems, small systems, and everything in between. Systems that can streamline your local operations or link up to form worldwide processing networks. Datapoint, a company dedicated to progress, committed to research, applying computer power to the varied needs of the business environment, designing systems that handle all of the company's data processing functions, or extend the benefits of computer power to remote locations. And InfoSwitch, computer-based systems for voice communications management, to bring the high costs of business telephone use under control. Datapoint, offering you a clear, coherent philosophy of product design that virtually eliminates obsolescence, bringing you a compatible family of computer hardware and software that grows as you grow. You don't have to throw away your valuable software investments because the powerful 6600s you're using today run the same programs as that 2200 you started with in 1970. Datapoint, a company concerned about the people side of data processing, delivering computers that don't have to look like computers, friendly computers, designed to fit right into the places where there's work to be done, driven by high-level software that makes operations a snap for anyone to use. Datapoint, a responsive company made up of dedicated people, led by a strong management team, selling and leasing computer systems nationwide in over 50 countries around the world, on 24-hour call from anywhere in the country at our customer support center to keep you productive. Datapoint, a company with a history of success. Datapoint, a big company that's getting bigger fast, growing on a solid financial foundation, located in San Antonio, Texas, and around the world. With over 25,000 computer systems installed, a company that's still keeping its commitment to provide the best possible computer systems and the best possible support at a wide range of affordable prices. Datapoint, a company with a future, expanding the frontiers of innovation, pioneering the electronic office of tomorrow, making dreams a reality by putting computers to work for your business today. Datapoint, we make computers.
Before, changed the way the world uses computers with the concept of dispersed data processing. A simple idea, really, but one whose time had come, because companies with investments in big central computers were running into problems. Their big computers kept getting bogged down by the load. thousands and thousands of tasks daily, until Datapoint showed how a force of smaller, decentralized computers could handle a lot of that load. Located in functionally dispersed parts of the business, where data processing demands originate, Datapoint computers got more work done without adding to the mainframe load. Since then, dispersed data processing has saved millions of dollars by reducing computer costs and improving business operating efficiency. But business data processing can still bog down as a result of the conventional way of building computers. Dispersed computer or centralized mainframe. Any conventional computer has limits to its capacity to do work or to grow. Trying to make do with one overworked computer puts all of the business eggs in one basket. If that computer fails, the entire data processing operation grinds to a halt. Replacing an overloaded computer with a bigger one is often quite expensive. Upgrading to a larger machine means that until workload catches up with it, valuable capital is tied up in a costly, underused computer. Adding a second computer to share the work may solve one problem, but create another. Because splitting in two the store of information, the database they must hold in common, leads to more overhead in duplicating files maintained by both computers. And again, a limit is quickly reached, and you are stuck. Is there a solution to this dilemma? A modular architecture that allows for incremental growth at predictable costs? Using equipment that won't become obsolete with each new model announced? A system that allows many users to perform many different tasks without wasteful duplication of the database? Datapoint presents the solution. Another idea whose time has come. A simple way to rival the power of even the biggest computers without their disadvantages. Based on the idea that the way to obtain X amount of computer power is with X number of computers. Not bigger computers, but small computers working together as never before. Relying not on special new machines, but on the proven advanced business processors Datapoint customers have used for years. This innovative concept is called attached processing, and its realization is called the Attached Resource Computer, ARC. ARC, comprised of as many resource units, or as few, as a business may need, in an endless number of possible configurations, because ARC's growth and shape are determined by each company's own functional requirements, not by conventional computer system architecture. How can ARC solve all of these problems? Conventional computer systems make the central processor fulfill at the same time the basic system functions of applications program execution, disk file maintenance and retrieval, and the organization of internal communications, with the result that it does all of them more slowly. But ARC distributes these basic functions. It lets them be handled by specialists. The applications processor, workhorse of the attached resource computer, doing the actual data processing that is the whole reason for computers in the first place. Freed from time-consuming data storage and retrieval chores, it can now operate at record speeds to get more work done. The file processor, manager and master of the ARC database, responsible for handling requests for data stored in its disk units. Because this is its only function, it locates and delivers remotely stored data to other processors as fast or faster than they can get it from their local disks. All of ARC's processors are attached to the interprocessor bus, a sophisticated short-range electronic pathway that communicates data at extremely high speed. It's like having all of the other attached resources inside your own local processor for every user of the ARC system. As many applications processors can be attached to the ARC system as there are types of work to do. Online transaction processing with data share, batch processing with COBOL, communications to other computer systems with networking software. Even a company's central mainframe can participate in the ARC system as an applications processor through Datapoint's direct channel interface option, all at the same time. And more than one file processor can be put to work. With each new file processor, ARC's data handling speed increases. and so does its capacity. Users need not even know the physical location of the remotely stored information they share. ARC remembers where everything is in the collective database. What happens if one attached component fails? Suppose a file processor quits. Simply replace it with another processor from the system, and that becomes a file processor, with no system reprogramming needed. Data processing operations can be continuous, because now there are lots of baskets to put those eggs in. What if just one more workstation is needed for computer program development? An economical attached processor is the answer. Designed especially for the ARC system, it utilizes the common database of the file processors, combining the convenience of a terminal with the power of a small computer. Suppose increased business transactions create a need for 10 more workstations. Just attach a data share applications processor, and up to 24 video display terminals can be added to the ARC system. If security is a worry, attached processing holds the key. Information in the database can be restricted in several different ways, and if need be, each application's processor can have its own private files that only it can use. These changes require no operating system conversions, no reprogramming, no retraining, because processors attached to an ARC system continue to work the same as before, no matter how big the ARC gets. And if Datapoint computer systems are already at work for your company, you can make the transition to ARC with existing advanced business processors. And every program you now use will run the same on ARC, only better. Modular processing resources for virtually unlimited power. Data storage economically expandable to unheard of amounts. Higher operating speeds than ever before. Complete transparency to users of data handling and communications. There's never been a computer system like this. Until now. Until ARC. Attached processing. An idea that will change the way the world uses computers. The ARC system. From Datapoint.
Can you predict the future? Can you predict exactly what will be needed to run your business efficiently a year from now, 5 years from now, over the next decade? It's something to think about. It's something we're committed to. Since 1968, Datapoint has been committed to providing business computing systems designed to meet your present requirements while providing the foundation for your future needs. The Datapoint Corporation pioneered the introduction of dispersed data processing with modular hardware and compatible software as the key to growth. A standalone system, first used for basic business data processing, can be expanded to provide more storage, additional processing power, a wide variety of peripherals and additional software packages. This concept of a modular add-on architecture is the heart of the attached resource computer, ARC. The first computer system that can be expanded virtually without limit and without reprogramming. ARC local networks are at work now in customer locations worldwide, uniting computers, peripherals, and voice communications management systems with a cable-connected artery for high-speed information flow. Over the last 4 years, we've been constantly adding capabilities, more data processing features, communications management products, and enhanced software. Recently, we integrated office functions into the ARC environment with word processing and electronic message services. Now, Datapoint announces 2 new products with the power to meet the business computing needs of the 80s. The 8800 processor and an advanced operating system, RMS, the Resource Management System. These 2 products offer new power, new capabilities, and new flexibilities not only to the ARC user, but also to standalone systems. The Datapoint 8800 processor has the power to handle large jobs easily and quickly with multiple operators, multiple languages, and multiple functions. For the first time, you can have both the economic benefits of shared logic design and the performance advantages of multiprocessor architecture. Each 8800 may be configured with up to 1 million bytes of memory. If additional processing power is required, 2 or more 8800s may be linked together in a local ARC network, providing as much processing power as needed. With the 8800, you'll always have the online storage you need. Start with 200 megabytes of disk storage and grow from there incrementally up to 1 billion bytes per 8800. Adding storage is simple, and ARC ensures orderly system growth no matter how large your requirements. The 8800 offers you much more than just large memory and storage. Operating under RMS, the 8800 allows low-cost terminals to perform as full-function workstations. However, if a task ever becomes bogged down in a shared logic partition, it can be moved into its own partition with a dedicated processor. This ability to tune total system performance task by task without reprogramming is simply not available in other systems. A single 8800 supports a large number of multifunction workstations, handles large batch processing jobs, and concurrently does interactive processing and programming in multiple languages. The 8800 processor can interface to standard Datapoint peripherals, such as printers, card readers, and tape drives, fully preserving your current hardware investment. For data transmission to remote sites, the 8800 provides comprehensive data communications capabilities, allowing it to work effectively with both mainframe computers and other Datapoint processors. Modular architecture allows you to utilize as many of these features as you need. Each 8800 processor accommodates multiple printed circuit boards to handle different computer functions. Several of these card slots are reserved for required boards, but the remainder allow you to increase processor memory, to support additional workstations, to accommodate various peripherals, to permit remote communications, to operate in a local ARC network, or to offload the 8800 via internal peripheral processors for improved throughput. To offer such a powerful new processor, Datapoint had to provide an operating system that could fully utilize its resources. The new Resource Management System, RMS, is an advanced operating system that provides dynamic resource sharing and memory allocation with speed, power, and efficiency. RMS provides multi-language support on ordinary low-cost workstations. Programs may be written in high-level languages such as Databus and COBOL, and a powerful set of utilities help cut program development time. By managing the number and variety of resources configured in your system, the RMS system provides you with optimum performance. These resources include disks, printers, tape drives, workstations, and communications facilities, in addition to all processors and memory within the ARC network. For example, if a job requires information found on a specific disk, RMS will determine if the disk is available, and if so, will provide you with access to it. If your job calls for a line printer, just specify it. RMS allows each user to logically configure his own personal system within the confines of the larger system. A user can make use of any unrestricted resource on the system, even if the resource needed is in another room, on another floor, or in another building. All this is possible under both the local ARC network and over telecommunications lines to remote sites. Resource management also extends to memory. The memory required for a particular program or processing task is allocated dynamically by the system. You get the memory you need, while the system utilizes the remaining memory to meet other requirements. When you're finished, RMS reclaims the memory you used for other needs. The RMS system has the ability to manage large amounts of storage, allocating sectors to data files with almost no restriction in size. If needed, a single file can even consume an entire disk. RMS gives the user complete control over his system with full provisions for security and privacy. Every resource and every data file in the system can have multiple passwords associated with it. Only by knowing the appropriate passwords can the user gain access to resources, programs, data files, and utilities. In addition, each user and each data file can be assigned one of 10 security levels. If a user isn't supposed to see a sensitive file or use an exclusive resource, assignment of appropriate security levels and passwords will ensure their integrity. RMS makes more efficient use of your programming resources too. As new languages, new equipment, and other capabilities become available, they're easily added. And because existing programs don't have to be modified each time a new application is written, you save valuable programming time. The result, less program maintenance, more program development. When your needs have outgrown your existing system, when you need more memory, more workstations, or more storage, simply add on whatever is needed via the local ARC network. For large requirements, add 8800 processors. For small requirements, add 6600 processors. RMS manages them all. The add-on capabilities of the 8800 and the RMS operating system stem from Datapoint's commitment to a modular growth path, freeing the user from costly upgrades or reprogramming. This commitment is the foundation for ARC, the attached resource computer. In the ARC environment, the 8800 can perform both file management and applications processing. While managing data resources, it can also support user workstations, communications tasks, or peripherals. Or if you choose, the 8800 can be dedicated to data management or applications processing. System growth matches business needs easily and economically. With its modular design, your ARC system grows step by step with your business. ARC lets you budget for current needs while providing the flexibility to meet future requirements in cost-effective increments. No other system offers you the flexibility of total resource access, local and long-distance networking, and system growth without loss of performance and without economic penalty. Like all Datapoint products, the 8800 processor and the RMS operating system are compatible with other Datapoint products, including the 6600, 6000, 5500, 3800, and 1800 processors, the 3600 and 8200 workstations, existing printers, and peripherals. As powerful as the 8800 processor and the RMS operating system are, the ability to meet changing technology and changing user requirements easily and efficiently has been designed into both systems. The future, it's unpredictable. That's why Datapoint business computers are designed for the only thing management can predict with certainty: change.
DataShare is a product that comes out of the history of Datapoint Corporation. Hello, I'm Kirby Heron with Datapoint Corporation. I'd like to talk to you a little bit about the history of Datapoint. We started back in 1968 as Computer Terminal Corporation, supplying a solid-state replacement for teletypes, in effect a glass teletype. With this success in hand, in 1971 we reincorporated as Datapoint Corporation and introduced our first product, that of the Datapoint 2200. With this early involvement in the traditional data processing industry as a background, we then chose to venture into and deal with the dispersed data processing networks. The concept of dispersed data processing was introduced by Datapoint in 1971. This introduction was based on another concept, that of intelligent data entry. By intelligent data entry, we mean the ability to put terminals in the hands of the users at the remote location. And through the use of those terminals, those people in those remote locations, where the data is, can do the entry themselves. That means that the people who are doing the work are the people who are most familiar with the information being handled. Now, this intelligent data entry system also provided many editing functions, an array of editing capabilities such as table lookups, range checking, check digit verification, those sorts of things. The idea is that as the information was being entered into the system, any errors could be detected right then and corrected by the people who knew the information and who were dealing with that information on the spot. In addition to that basic idea of gathering the data intelligently, we also were able to, for multiple users, capture their information, store that information on a local system, and then subsequently forward that information via telecommunications to the host mainframe. Now, that provided many benefits. The primary benefit being the information handled where it is. We also were able to save a lot of time and effort on the side of the mainframe, because when we did introduce that information to the mainframe, the number of edit runs, error reports, those sorts of things were greatly reduced. Now, that system was DataShare. DataShare is the system that provides this intelligent data entry to multiple users at the same time. The system was originally based on the Datapoint 2200. It's a 16K mini computer, very friendly looking, as you can see, does not look like a computer. But based on that small, comfortable, business machine looking system, we were able to provide many of these services to our users. Now, Data Bus is the language that we use to subsequently handle the multi-terminal environment via DataShare. Data Bus as a language is broken up into two pieces. The first piece is what you can look at as working storage. It's the information that the user is dealing with right then, adding, subtracting, those editing criteria. There's then what you might call the procedure division. And that's where the function gets done, the add, subtract, the reading of information, and the writing of that information. The original DataShare system allowed up to 8 users at the same time to share the resources of the Datapoint 2200 mini computer. The 2200 is a 16K machine, as I mentioned a little while ago. And through the DataShare interpretive system, we allowed up to 8 16K programs running in a virtual mode. Now, in addition to that, the system had, of course, disk storage. In those days, that was a little 2.5 megabyte disk, 1 removable cartridge, and 2.5 fixed disk. Of course, there are also printing capabilities for reports either locally prepared or prepared at the host mainframe. Now, the connection to those terminals out in the remote locations was based upon what we call the multi-port communications adapter. And this is one of the MPCAs. Now, you'll notice on this side there's a series of connections. Those connections are an RS-232C interface connection. That means that the terminals can be connected fairly close to the system just via some cable, or they can also connect to telephone lines, which means that remote location may be New York City, while the 2200 might be sitting in Los Angeles, as an example. Now, in addition to the processor and the disk, the printing capability, and of course the terminals, we have other peripherals available on that system. Magnetic tape is available, card readers, those sorts of things. And of course, communication. The real idea in those days was to capture that information, transmit it to the host mainframe, receive back reports which we can produce locally, and support that intelligent data entry function. Now, with that system as a base, we have now had 8 years to mature that product, 8 years to provide additional features to that product that our users have asked for. DataShare, like any good product, has had several renditions, using that maturity to bring forth a better product every time. An example is DataShare 3, which was introduced in 1973. One of the things that DataShare 3 gave us was the ability to handle more than one type of terminal directly into the system. When we started in the 1972 time frame, it was our 3360 terminal, very much like the teletype. In 1973, we also introduced our 3600, Now, this was less expensive than the 3360, plus it had additional features. DataShare 3 allowed a user to have both of those terminals on the system at the same time. Flexibility as well as these key components. Those were the things we were really seeking. In 1975, we introduced the 5500 processor. The 5500, as you can see, is identical on the exterior to that of a 2200. However, it is a 48K machine, much more memory. It is a much faster computer. It has a larger instruction set, so we were now able to do significantly better things and more of them than we could handle with the 2200. One of the major requirements identified by the customers was the number of terminals being handled at one time. As we said on the 2200, it was 8 terminals. Well, now with the 5500, we provided the capability of supporting up to 16 terminals concurrently. In addition to the 5500, we also made some other introductions. Another type of disk with significantly more storage available to it and also significantly faster than the original disk system we provided. Other printers have been provided. Faster printers, more volumes being required in those remote locations. And of course, we continually enhanced our communications capability, still providing that release of information for the host mainframe. Now, we do want to touch again upon the fact that this machine looks the same and it operates almost identically. And a key point there is the investment in software. We had a large investment in our software, the DataShare system and all the utilities attendant to it, and our customers had very large investments in their application software. The introduction of this machine was such that all of that software, ours and theirs, continued to run. It just ran faster. This is the philosophy of Datapoint, to provide better product to you, but with minimal conversion effort and certainly minimal expense. Even with the introduction of the 5500, our users still were not satisfied with the capabilities provided and continued to ask for more. Some of the ideas that they had were in the area of more terminal capabilities and whatnot, but also additional ways to manage those remote systems, to deal with networks, and make better availability of those resources they already had. So in 1975, the latter part of 1975, we introduced DataShare 4, the next step. This next step provided 2 very powerful capabilities to the user. Those capabilities are, first, DataShare networking, or DSNet as we call it. Now, DSNet is not a separate facility, but it is an integral part of DataShare. An example of the use of DSNet would be where I've got a good-sized central DataShare system, and in the remote location, for instance, the diskette-based data entry machines. Now, there's a certain amount of the editing and validating that can be taken care of in the remote location. That remote location can then dial into the central machine, use the resources, the additional database and all of that sort of thing at the central. The resources of the remote are also available to the central machine. Now what that means is I can bring information in, do a supplemental edit to it, and if in fact errors are detected, I can go back to the printer on that remote system and immediately print that report. That means that the turnaround for error corrective procedures can be immediate and in place out there in that remote location. Some information over here that will show you graphically how that system operates. The second facility provided another communications mechanism that we call multi-link. Multi-link, again, is an integral part of DataShare. It is no more than a telephone line handler. What that means is I can do, for instance, an interrogation of my local data. If the information is not available locally, I can immediately route that request to another system, perhaps a host mainframe, perhaps another Datapoint system. The answer can then be derived from that other machine, brought back, and automatically provided to the person at the terminal. Now, that's a very simple concept, and it turns out that it's very simply implemented via very high-level statements. Send and receive. That's exactly how simple it is. There is used in our international market an additional multi-link mechanism called pole link, by which multiple terminals can sit on one telephone line. The users again came back to us and said, I need a little more in the way of capability. So in 1976, we introduced the 6600. Again, it looked like a 5500, which looked like a 2200. It was still friendly, easily used. However, again, it was significantly faster than the 5500. It had up to 120K of memory, so we got more users, more information available to the users. It was able to now support 24 concurrent tasks. So we went from 8 on the 2200, 16 on the 5500, and now 24 on a single 6600 system. In addition to the 6600 processor, we announced another type of disk. This was a 10 over 10 disk, 10 megabytes over 10 megabytes. 10 megabytes removable, 10 fixed, and you could hang additional drives in either 20 or 40 megabyte increments to go up to 160 megabytes on one machine. This, of course, did not fully complete the requirements of the users. So in 1977, we took another very, very major step, and that was the introduction of ARC, the Attached Resource Computer System. And with the ability to link as many of these 6600 processors up together, I could now have as many terminals as I could ever hope to imagine. With the introduction of ARC came the introduction of DataShare 5. DataShare 5 took advantage of the facilities of ARC, and one of the major points in DataShare 5 is it provided a mechanism by which many, many users could go after shared information, common data files, and DataShare 5 would then resolve the conflict between those data files so that information would not be mishandled. An additional peripheral that we provided with the ARC announcement was what we call the direct channel adapter. This is an interface mechanism by which we hook directly onto the IBM and IBM-compatible byte multiplexer channel, again opening another path of information flow between the host mainframe system and the Datapoint system. It is faster, of course. It does not have to adhere to standard telecommunications mechanisms and speeds. Another advantage. That leads us up to right now, today, and the next version of DataShare is being made available to you, and that's DataShare 6. Now you ask, what does DataShare 6 provide to me? There are 4 major points that are being addressed with DataShare 6. Performance. Over the years, we have paid a price in performance to get some of these features. DataShare 6 gives you that performance and maintains those levels of features already available. The next point is AIM. That is the associative index method, a totally new concept in data handling, a totally flexible mechanism for you to deal with the data the way you want to rather than the way the computer used to tell you to. Next is an increase in user data area, so that now each program can handle more data at one time, more counters, more information. And last is a new change to our utility partition supervisor system, where we can now take much better advantage of the memory available on those machines, which takes us back to performance. DataShare today is available on large or small systems, as large or as small as you need. We can have the small 1500 system for a standalone or relatively small operation, the 1800 for a little more speed, more terminals, more disk storage. These are floppy diskette-based systems, by the way. We could go to a standalone hard disk system, such as a 6600 with 20 megabytes of disk. And of course, we can go to ARC to encompass virtually as large a system as your business can grow to. DataShare as a system is evolutionary, not revolutionary. It is designed to help you address your business needs. The system is available to you quickly from the time you order the appropriate hardware until that hardware is delivered. You can get that system up and running quickly. The system is easy to use, easy to program, and easy to manage. And it's available now. Hello, I'm Kirby Heron. I'm here with you today to talk to you about DataShare 6, the latest version of DataShare provided by Datapoint Corporation. Before we talk about DataShare 6, I'd like to tell you a little more about DataShare, its history, and how it's brought us to the latest version. DataShare was developed back in 1971 by Datapoint Corporation. It is a multi-user time-shared business system. It is directed primarily toward transaction processing, although it certainly handles batch processing functions as well. The history of DataShare has been that of constant growth, an evolution of a product to address your business needs. This latest version is going to provide again to you some significant benefits that I'll talk about as we go through. DataShare today, as I mentioned, is a multi-user, multi-tasked system. Provides up to 24 concurrent tasks operating on one processor. These tasks can be managing a terminal, managing a printer device, managing a telephone, or a variety of other functions. Data bus is the language that we use to write the programs for the DataShare system. Data bus is a very high-level English type language comprised of two pieces: the user data area, or working storage, and then the procedure division, or actually getting the work done: add, subtract, multiply, divide, and whatnot. DataShare today has a history of 8 years of maturing. This maturing process has enabled us not only to bring you a better product, but a more fully featured product, more carefully and fully addressing your business needs. Now, let's look at DataShare 6, the product we're here to talk with you about today. We have 4 new areas that we've addressed with DataShare 6, the primary one being performance. Throughout this 8-year history, we traditionally have added features at an expense somewhere else, less reactive in throughput, as an example. Our primary objective in this product introduction is to give you added performance and yet maintaining all of those features you've taken advantage of in the past. In addition to that, the second major point is AIM, the Associative Index Method. This is a new access method that we developed through our word processing products, and we found it to be very, very well accepted and used by that part of our user community. AIM is now available within DataShare to provide more flexibility and more capability in using and dealing with your data. This flexibility is so that you can deal with your data the way you want to, rather than how a computer normally tells you how to do it. Another thing that has been brought out is greater UDA, the user data area, where I keep my information on my data, where I keep my counters, those kinds of things. The user data area has now been expanded up to 15.5K, or 15 8,500 characters of information. Last and certainly not least is a new utility partition system. What that means is that I can do functions other than data share in one partition, and in the other partition have all the facilities available of data share 6. The memory management facilities available in data share 6 are identified here, and I'll talk a little bit about each of the improvements that we've addressed with this version of data share. First is the increased minimum virtual pool. The way the system operates now, you must always have 16K of virtual pool available. This may sound at first like a restriction, but in fact it's a guarantee of certain performance characteristics. The second point is, of course, that we have now increased the maximum size of the virtual pool. And this is very, very important. As you know, some of our machines, specifically the 6600, can get up to as much as 256K. This system now allows us to take advantage of every page of that memory, up to and including 192K in the virtual pool alone. That does not take into account the interpreter, the operating system, and whatnot. Up to 192K of just virtual. Another major point is that all of the memory is now used. For those of you who are familiar with some of the previous versions, because of the way we manage memory, in some cases we couldn't take advantage of pieces that were left out. In this case, we use every piece of memory down to the page level. Next is an elimination of the class restrictions in the virtual pool. Now, by that I mean, in previous versions of data share, in the virtual area, we only allowed you to have the data bus code, the interpretive code resident, and the intermediate ISI information, because that never changed. Well, with the other facilities provided here, we have removed that restriction. So now in my virtual, and using as much as is available on that machine, I can put any type of information in there, including data bus code, text information, AIM information, index sequential information. Another change in the scheduler area of data share 6 is the ability now to directly address all of the virtual pool without having to do block transfers within memory. And obviously this is much, much more efficient than the prior versions. Last is the fact that because of the direct access to all the virtual areas, I now can remove any size restrictions on the interpreter itself. Now, that's not to say that the interpreter itself has grown, but it provides us and you an ability to grow, to add more features to the system and never have a boundary encroaching upon us. The next point is AIM. That is the associative index method, a totally new concept in data handling, a totally flexible mechanism for you to deal with the data the way you want to, rather than the way the computer used to tell you to. Now I'd like to tell you a little more about the AIM file itself. The AIM file is created by a system utility provided by Datapoint called AIMDEX. The AIMDEX utility, based on your instructions, will create an AIM file pointing into the data set that you want to deal with. With just the one AIM file, we can now provide multi-keyed access to that data and multiple arguments for those keys. The easily used components of data share that handle AIM provide to you the ability to add records to an existing file, delete records, update existing information, insert keys where, for instance, a record could have been added by another access method. The flexibility available there, again, is immense. Now, specifically, The AIM file, when initially created, will use at least 252 sectors, and that will provide pointers into 1,000 sectors of data information. From that point forward, with your additions and inserts and whatnot, the growth of the AIM file will be 14% of the data that you're dealing with. So you can see we're being very economical in the use of the disk, and at the same time providing this new, elegant access method. Now, as AIM is being used, there are basically 4 types of searches, 4 types of search facilities that you can make available. There is a class-type search, partial information search, non-unique search, meaning I don't have to be unique in my data requirements, and multiple-level file handling. Now let's talk a little bit about each one of those techniques and what it can do for you and your business. The first one I mentioned earlier was that of a class-type search. This could be used as an example for a parts system, let's say an auto parts, a warehouse, or whatever. A customer calls in and says, I need this part, but doesn't know the part number, color, or any of the other characteristics. But they know what that part does. As an example, a gasoline line. Well, based on that information, I can now do a class-type search looking for all gasoline lines within my product line. Based on that, and in talking with that questioner, provide that answer. An example would be a power supply in the parts file that we use at Datapoint. I think that TRW is currently a vendor for power supplies. My search will use the description field freeform, and I will key in power for that search. In the vendor field, which I will also use, I will use left justified search and enter TRW. As the next question occurs, the display mode, I indicate continuous, and I immediately see the only type of information that TRW supplies, which is power receptacle. I now must look elsewhere for my power supply. Another area that traditionally has been very difficult to address in standard access methods is partial information search. Now, for instance, in ISAM, there are ways to do it, but on a very minimal level. Only left justified. You must have a reasonable amount of the information available for the key. Well, with AIM, and if you have partial information, regardless of the position of that partial information in the record, that location can still occur. Now, a partial key can be left justified, it can be right justified, it can be identified to be freeform anywhere at all within all of the data or within specified fields within that data. Also, with a partial key, there is an ability to have don't care characters in there, where I may have 2 parts and I don't exactly know what's in between them. So I can have don't care characters, and that's a very, very unusual ability for accessing data. I have been given a note to get information about a transistor and TMS. 2 of the characters are scribbled out and I can't read them, so I will use I don't know characters in their place. I key in transistor and the I don't know characters or I don't care characters and continue the search from there. This is a freeform search in the description field, and as you can see, the response to that request is very quick. Non-unique keys. That has always been a severe restriction in index sequential systems, as an example, that if I, using my prior example, have 100 types of transistors in my file, then ISAM does not lend itself well to that. And AIM doesn't care, still provides you with the ability to access your data the way you want to and need to access that data. I need to find all of the transistors currently in our inventory that we get from Motorola. I identify the system that I want to look in the description field, freeform, and find all the references to transistor. Having completed that, I also tell the system I want to look in the vendor field, but in the vendor field, I want to look at it left justified. Based on the left justification, I can just key in the word MOTOR for Motorola, and this will provide enough information to do the search. The next thing, of course, is to tell the system to just step through the next key function and begin displaying the information I want on the screen continuously. With the screen full, I can now see every piece of transistor provided to us by Motorola. Another approach that AIM can facilitate is that of multi-level file searches. Traditionally, data processing files are not necessarily similar to one another. As an example, I might have an inventory file and a vendor file, and those probably don't look anything like each other. The field definitions are different and whatnot. AIM allows that problem, that restriction, to go away in that I can, for instance, look through my inventory file to identify an element that I need, and then using that full product description, go into my vendor file to see the most appropriate vendor to service that need, the best price, the best delivery time, that sort of thing. So using AIM, you can do information retrieval from one area, using the results of that, then cascade into the other files appropriate to your business to support that need. Now let's ask who can use AIM. Just about anyone. The list of existing and potential users of AIM is long and outstanding. The system is easy, flexible, and ready for you right now. DataShare 6, the latest version of DataShare, bringing you that performance that you needed in addition to the features that we've always provided in DataShare. DataShare 6 giving you AIM, the associative index method, providing that flexibility to deal with your business needs and your business data the way you want to, rather than the way the computer tells you to. Datapoint has again addressed your business processing needs. DataShare 6 addresses those needs very, very well. DataShare with ARC, word processing, electronic message systems, communications management products, and the other data processing facilities available. The Integrated Electronic Office is here, and it's available for you.